Okay, in this talk, I will be basically talking about object detection in images and videos. These topics, before coming here, I tried to Google it, how many people are working on this. So there were a lot of researchers working on these topics, and almost 1 million searches came up when I tried it in Google. Basically, in these topics, first I will give you the examples of this object detection and in videos and images. Then I will little bit talk about the process for that, and then I will move into the research and development tools which is available in the market and people are using that, and also the problem with image detection. Basically, object detection in images or videos is like, let's say if I capture image here, so it's very difficult to recognize the people here. So what we need is we need the data first, and then only we can recognize the persons in this room. Also the objects in this room, first we need the sample of the images, and then only we can recognize those objects in this room. So basically there are a lot of experiments being done worldwide, and there are they are making challenges in worldwide, and they are collecting different kinds of data. Basically, the challenge is we need the data which is labeled. It means, like, let's say we have fans here. So if we take the pictures of the fans, or if we take pictures of curtains, then first we have to label it as fan or curtain, or if we take picture of camera itself, then we have to label it as camera. Otherwise, when we want to detect those objects, it will be difficult to identify in this cluster. Like, there are many peoples in this room, so it will be very difficult to detect those. Okay, so So basically, when we talk about object detection, we have to talk about detecting objects from the two-dimensional images. Like, if you capture a picture, what we have is we have a 2D sample, right? It is a basically digitized version of what we have in this real world. So by object detection, what we mean is we have to identify those objects in this scene. Like, what we have to do is we can have multiple kind of objects. So the first process is like, there is, you can see in the image, there is a grass and a sheep. So one case is we have to identify it simultaneously. Next case, so this is a complex building. So and you have to identify the location exactly. So this is another complex task. Another thing is it's related with the context. So if you have a monitor, or if you have a screen, then there is a chance that there is a keyboard and there is a mouse. So without even identifying, let's say, if you see this, if there is a computer, and if you see the computer from that side, even if you don't know whether there is a keyboard or not, you can say there is a keyboard, right? So it's like that. So you have to use the context to identify okay, so these are another examples, right? Yeah, you can see in the first picture there are a lot of peoples. In the second picture there is a single object. In another picture there is multiple objects. In the first picture, most of the objects are same. There is people. In the second object we have bicycles and we have motorbikes and we have people also. So in other images we have different kinds of objects. Okay, so and another thing is like you have all of you are using Facebook, and the Facebook is using the face detection tool. So it exactly identifies the person. So the thing I want to say is like in the Facebook, there is a face recognition system. To develop this kind of system, what they have to do is, this is a trick which Facebook used. At first, what Facebook did was, it gave us the feature of tagging of photos, right? So people tag the photo. So after that, the Facebook knew that, okay, this, as I said before, we need to know, like there are many people in here, and first to use a machine learning system or to detect the object or to detect, let's say, face, what we need is, we need the exact name or exact identification for that face. From Facebook, they developed one feature that is called face tagging. They collected the data from the individual person. So, and actually, a lot of people are there in Facebook, and there are a lot of friends. So, based upon that, they collected huge amount of data when a person upload the pictures of their friends or their relatives. So, based upon that, they develop a system by which they can recognize the person. So, these days we can see automatic face detection. So, the name pops up there, and in some cases, the name doesn't pops up. Another case is like, what we have to do is, it's not about detecting the object, it's about detecting the details of that object. So we have to think about that also. And the practical examples of this object detection is like, we have heard about Google car. So navigation, automatic navigation system. So for them, what they need is like they have to follow the traffic rules, right? So these traffic sign recognition mechanisms enable these automatic vehicles to identify the traffic sign and follow the traffic rules. And another thing about assisted driving is like in our trial, like if for bike or for car, if you go in a trial center, what they do is they see the lines, right? And there is one dedicated person who is seeing the line in that trial center. But by using this object identification, like what we have to identify is, we have to identify the car, whether that car is in the line or not, but it's a very difficult task. One of the students from Kulchuk, they tried that, and it was very difficult task, and they actually were not able to accomplish it with good results, but still they produce some results. So, but anyway, this this line tracking, identifying the line, when the object goes to that nearby line or exactly touches that line, it's a very difficult thing. Like because the images which is captured from the cameras, so and that camera may not be of high resolution, and the angle from which that image is captured, it's not able to detect the 3D location of that object properly. So what we have to do is, now there are you have heard about different kinds of hardwares, like the Microsoft has developed a system, and based upon that they have actually it's about when you talk about computer vision, you have to do trade-off between hardware and software. Like a single camera can detect 3D images, 3D locations, but it's very costly. So you have heard about Kinet, right? So some of you have heard about Kinet. So what it does is it models the 3D. It actually models the 3D of an object. So, but it's expensive. So by using this software technology, basically computer vision algorithms, what we want to do is we want to develop an algorithm which is very efficient and less costlier. Okay, so another thing, it's very popular. What we can do is we can search based upon images. So if you want to search, now let's say in Google, these days what we do is we search based upon text. We search based upon images. And another thing what we do is you can see when you type in Google, you can see images, videos related to that text also. So the challenge now is, what we need to do is we have to relate text, images, videos, and even audio signals. So now the next challenge for us is that. So this image search is one of the example. So another thing, this is one of the sample video, which is done by one of the students in my lab, and another aeroplane, and okay, this is a video collected from YouTube, and we tried to detect the object, and you can see some of the portions are detected, but you can see this bus is detected as car, right? So so that's why. And this truck is also detected as car, right? So it's very difficult to identify. Okay, let's see another video. It's about real-time event detection for video surveillance application, and basically you can see in sci-fi movies, right? So how the Terminator, in Terminator, the person is exactly identified, right? With even with its age and all these things. It's a very difficult task. Microsoft is working on a perceptual intelligence where they are working on identifying the age based upon images, right? The captured images. So it's very difficult. Yeah, you can see the object is exactly, the moving object is exactly identified. So this is a very challenging tasks, and also the running person and changing person is identified. Okay, so what we have to do? So from images, what we have to do is you probably most of you are using Paint or Photoshop, and there is some option to crop those images, right? So you can just identify the background, and then you can delete that background and get the object, right? So it's like that. So here, for the background here, it's not easy to crop, right? So if the background is like, let's say the background is white, you can easily crop the object, and you can detect the object. So our target is to identify the ages related to those objects. So you can see these objects, and if we can identify the ages related to these objects, right? Based upon those ages, we can get some idea where the object is located first thing, right? Where the object is located, and then we can work on the exact identification of that object. So basically, when we talk about object detection, we have to identify whether a person is located in this object or not, right? So if we talk about object recognition, we have to identify the number of objects in these images. There might be 5 objects in these images, there might be 10 objects in these images, so we have to identify those things. So basically, the thing what we have to do is, we have to first identify 3D objects from the images, and then we have to determine its scene position, its location in the scene. And to determine the object, it's very challenging, because first we have to identify where that object is located in that picture, and then we have to compare that particular object, which is not yet identified, with the standard objects, and then only we can say whether that object lies in the list of the images we have in our bank. Okay, so first we have to see the scene, right? We have to recognize the scene. There is in Google, right? In Google Photos, there is an option where Google automatically detects the picture. Basically, we can say it's scene. Like, it can identify whether the photo is portrait or landscape. It can identify whether the photos are of flowers or animals. Okay, so probably in 2012 or something like that, there was one scandal with this Google photo, this scene recognition system. I can say that like that. So what the problem was, they have the features. It identified, it was working correctly till that date. And one black guy, he uploaded his photo, and his photo was tagged as gorilla. So what the problem was, because probably he was smiling, or the features that. Now I am moving to the important thing in the image and object detection. What we have to do is, the image which they have trained, right? The image which they have used to train the system, it was telling that the image of the black person is like a gorilla. So the model which was developed at that time was not accurate. So either they have to train more images, put more images in the system, or what they have to do is they have to break down in the images in such a way that the black person and gorilla is separated, right? So that's what we call as feature extraction. Feature extraction is necessary in each and every signal processing, or even so if we talk about text processing also, we need a feature. So what feature is, let's say if we are talking about a person, right? So by our visual perception, we can easily identify the feature of each and every one, right? So let's say what we can say, the color, one of the feature is color, another feature is the eyes, another feature is nose, another important feature is whether the face is circle or it's oval, all these things, right? So all these things has to be detected, and based upon that we can say whether the person, whether that detected object is a gorilla or a person, right? So Google revised their algorithm and it was able to detect that. So when we talk about object detection, we have to talk about classification problem. So what a classification problem is, we have a list of candidates, right? Let's say we record all the picture of all of you, right? So, and next time when we take a photo of one of you, so the system should be able to identify one of you, right? So all of you will be considered as a class. Let's say you are probably 125, right? So 125, we have 125 separate objects, right? But face recognition, it has some, all of you have some similarity. So based upon that, we can deploy one similar algorithm to identify the face. So basically, what we do is we deploy one, we develop one model, and based upon that, object is classified to a group. Okay, so and when we talk about computer vision, we have to talk about classification, and we have to talk about object detection. So classification basically in a single a single object is in image, right? So what we do is we first identify the position of the object in that image, right? So in earlier side, what we saw was their counters were detected, ages were detected, right? Based upon those ages, we can say that this object exists in this position of image. So then this identification of the object is basically, or we don't know exactly whether that is a class, a cat or a dog, but still we know that there is an object in that position, right? This is called localization, identification of the position of the object in the scene, right? So we first localize it, and then we check. We have the list of the objects. So we took that object and we match with the list of the object we have in our data bank. So based upon that, we do the classification. And so if we are talking about many objects in a scene, then first we have to localize each and every object in that images. So we have to identify the positions of that object in the image, and then after that we can match with the classes we have in our bank. So basically what we do is we I'll not go into detail. So in these diagrams, basically we have a local feature extraction method, we have a global feature extraction method, and another case is like we have we identify the object based upon their colors also, right? So, and another thing is there is a. I will talk a little bit about this, right? So, in this, let's say in these images, what we do is after the introduction of this deep learning, right? So before it was very difficult to identify a large number of objects in a scene, and it was even if they were able to identify the objects, it took very long time. But after the introduction of the deep learning, one of the component is convolution neural network. So what they do is they identify the regions here, and they process these objects or these regions in a different layers, right? So that the property related to that object remains valuable, and it's possible to identify even the complex objects. And basically, it was not possible to identify. Let's say the challenges we have is we can have the pictures from different directions, right? And we can have the pictures captured with different illuminations. We can have pictures like this. So some of the scene might be missing in the scene itself. And we have another thing like there might be two laptops, but it's in a different scale. So we have to recognize it. And also there might be deformation due to the movements of the objects also, right? So, and also if the background is too complex, it's very difficult to identify the objects. And also another thing is like we might have multiple classes of the same objects. The chair can be of different variety. So, and also the challenges is like the image can be captured from complex background, and another thing is the resolution of the captured videos or images, right? And if we are talking about the moving object, so we have to talk about the speed of the moving object. And also right now, what we have to think is like there is the new number plate given by the government, right? So why they are planning to install this? Even with the low resolution camera, right? Even if it's moving, they want to identify exactly the vehicle's number plate, right? So they want to do so. For that, we need a system which is capable to process in a real time. So these are the challenges, and so there are different approaches and different algorithms for recognition. So first thing is like we have to detect the ages, right? So age detection algorithms are available, and another thing is we talk about detailed features of the object, and there are the descriptors. And also when we talk about the color intensity and the variation of intensity in the images, we need to talk about histogram, image intensity and histogram, and there are different methods to calculate the level of those intensity variation between the images and videos also, right? So we have to talk about those things. And finally, based upon, so basically all these algorithms will be used to calculate the features of the objects in the images, right? So, and based upon those features, we use a classifier to identify whether our object falls in the category or not, right? Okay, so, and then another challenging thing is, right, okay, so let's say somebody is stealing an item from Bharvarini supermarket, right? they have a CCTV camera, and how to detect whether the person is stealing that object or not. Probably he might have removed the sensor, right? So we have to detect that and identify, and we have to blink the alarm, right? One case was already seen in one of the Badvadinis. Like, one person went to Badvadini, he changed the dress and went outside, right? And it was very difficult to identify whether that person left with the dress or with a new dress or not. So probably if we have some mechanisms to identify the objects in the supermarket, then, and also important thing is like this will be one of the important research going in retail industry. Like, so you all are wearing different kinds of dresses, right? And different kinds of brands. So we have the image, we can have the images and videos from this room, right? So we can clearly say which brand is popular, which color is popular among us, right? So all these things can be identified from the images or videos. Okay, so when you talk about images and object detection, right? So we need to talk about different kinds of image data sets, right? So now, so image detection first, it was very, as I said before, so we have to follow different kinds of steps to identify the objects in an image. One of the basic thing is the character recognition and digit recognition. And let's say if we tell you, right, if I tell you to write different characters, let's say digits, all of you, and then we build a system based upon your digits, right, the digits you have written, then definitely it will be able to identify the digit if I wrote one of the digits, right? So it's like that. So for that we need to validate whether the person has correct, whether we have written which digits. So to identify those, we have a one minis data set. Another thing is like all these data sets are popular data sets. That's why I'm sharing with you. So, and this is a cipher data set, and actually basic it has different aeroplanes, right? So if you train the model with this data set, then it will be able to identify 10 different image classes. All these classes, right? So another thing, so this is one of the very popular databases, right? ImageNet, and it's also collected based upon one challenge. And here you can see different kinds of images with different orientations. And the important thing is these images are attenuated, right? Attenuated means first thing is, let's say we capture the image here, and we have to tell to check whether our system, the model we have developed using machine learning algorithm. So if we have to check whether the system is performing or not, what we have to do is we have to validate it. So to do the validation, they have given us the data sample where they will say that, okay, this is a dog, its position is here, right? And it is, and they have also marked it as dog also. So whenever we test our algorithm with this data set, and if the dog is identified correctly, or if the car is identified correctly, if any other samples are identified correctly, then we can say that it will work in the real-time system, right? Okay, so and actually they have 1,000 categories in this system. And also this Pascal VOC is also very popular, and they have 500,000 images, and also attenuation is like this. So what they will say is, okay, this chair in one of the images, the chair image is not here. Okay, so if this is a chair, right, they will write the positions, okay, X, Y coordinate, this coordinate, this and this coordinate in this file, right? So after identification of the object, you will check whether you have identified the location of the object correctly or not. And then what you will do is, if that is not detected as shear, then the classification problem fails, right? So there are two things. One thing is first identifying the position of the object, and next thing is classifying it properly, right? So the two things we have to talk, and another is Microsoft Cocoa database, and it has also large set of databases, and basically in this image, this is for multiple objects in images, so it has 5 captions per images, and this is probably the next presenter might be using one of these datasets for his image captioning. Okay, so there are other datasets available in different web pages. You can check the data from there, and also it's the image dataset it's randomly available, but video dataset there are very few places from where we can get the videos dataset. Okay, these are the datasets. And another thing I want to talk about is, right? Okay, so if you want to develop your application for computer vision, object detection, or machine learning, these will be the tools, right? First one is MATLAB. These days it's not that popular. When I was working, I was working with this MATLAB because there was image processing toolbox, and there was machine learning toolbox, and other like Python. It was not developed that much, and OpenCV. I was also using OpenCV, and basically now at the time I was developing my program using C++, but now it supports Python and Java interfaces also. And important thing is this OpenCV is also working with different kinds of mobile operating system. So if you want to develop an application using OpenCV, then you can develop it for mobile. You can develop mobile application as well. Another tool you can use is these are the Python tools. Scikit-learn is for machine learning library. Scikit-image is for image processing, and Theano. This is very popular these days, but it's already overshadowed by all other tools also. Theano basically it works with CPU. Oh, sorry, I wrote it should with GPU. Okay, it can run with CPU and GPU both. Basically, image. So in the case of images, one of the important thing is GPU is evolved for as graphical processing unit. So in images, what we can do is, let's say if you just want to scale the brightness of this image, you can pass this. You can break down these images into multiple parts and pass it to multiple processor, right? So CPU has limited processor, but GPU has multiple cores, and it can run in GPU, and it can speed up the processing time. Another very popular one, and it's widely used these days, and probably most of the researchers are using this TensorFlow. Airbnb, Airbus, eBay, Dropbox, Google, Intel, Coca-Cola, everyone is using this TensorFlow, and it can work with CPUs and GPUs as well. And another deep learning library, Python's deep learning library is Keras, and basically it is developed. It can work on top of TensorFlow, CNTK, and Theano. So you can utilize the features of these applications. And important aspect is like now you have to give the results in real time, right? So there are different tools in the market to process the data in real time, and Apache Spark is one of the tools which is used for real time analytics, and it has different machine learning algorithms also implemented, and recently they introduced Big DL, right? December 2016, and basically it's for deep learning library. So if you are thinking about implementing deep learning in a real-time system, you can use Apache Spark as well. Okay, so I will like to wrap up my presentation with the results which we have performed. It's now to run this different kinds of collect different kinds of images, and to recognize these images, we need a huge resource, right? So there are basically there previous techniques, previous methods use segmentation techniques like which I showed you earlier. So basically counter detection techniques, age detector techniques, and after identification of ages, then they use different kinds of classification algorithms to identify the objects. But now everybody is moving on to this deep learning. Basically, this as I told you already, after introduction of this deep learning, multiple images in the objects can be identified easily. So we tried one experiment with 32 CPUs, and also with 4 NVIDIA GPUs. And based upon that, we actually analyzed our result for different kinds of objects with the standard data sets. And basically with videos also we tried, and the results which I showed you earlier is with the system which we developed using TensorFlow. And you can clearly see the persons and objects are identified, and it uses the latest version of recurrent neural network. It's a faster recurrent neural network. And with videos also we try to identify, and this section is showing the actually error. And the important thing here is like we tried, because the images collected might be of different, might be distorted, might be with different orientation. So we tried for videos and images with different scale and with different orientation. So we tweak the images also. So based upon that, what we saw was for the case of videos especially, right? In the case of images, it's this recurrent neural network, and basically we use region proposal based recurrent neural network. And in that section, so what we can say is in videos, right, 2 image frames are related, right? So even if the object is not detected in one video frame, that object might be detected in other video frame, right? So based upon that, we can clearly detect the object in a video. And based upon that, you know about the ball tracking technology, right? Which is used in cricket, tennis, and all other sports. But the hardware they are using, right? So it's very expensive. So if we can use, they are still working on developing a very fast software system. They have to use a very high resolution camera and the high speed camera to detect the location of the ball. So we can minimize the cost of the hardware using very efficient and fast object detection. I would like to show you one video, and this video probably the sound we cannot hear. What this video is about is probably it's also showing caption now. Okay, so in Japan, They are now outdating this barcode-based system. Based upon they are using the camera, right? And they are just capturing the image. You can see there. She's capturing the image of vegetable, and the vegetable is all actually identified. So it's a very real-time system. So this is one of the very good application of object detection and the future plan. So the future plan, we have to improve. Still, we have to improve the accuracy of detection. And so, if you in the case of Nepal, so probably the transport ministry, which might be acquiring the very expensive software from abroad, probably from India or somewhere else. So it will be able to detect the number plate, but by using the open source tool, we can develop a system, right? It can detect the real-time vehicle's number plate, and we can give it to the ministry also. So one thing is that, and another thing is, like I already told you, we can identify the theft from the supermarket, and also the next moving thing is like the identifying the user behavior, right? So let's say if you go to the supermarket and if you see, let's say some dress or some items, and you can sometimes you can see that dress for a certain time, right? And you can think, and you can again put it that in the cell, right? You can go to another dress. So based upon that, how many objects of which brand are detected, right? So we can do a lot of analytics based upon that, and we can do the marketing based upon that. So another thing, like in future, this object detection, object identification based on searching on videos, and like it's these days videos are also being copied, right? So we can match the videos, whether that videos are related or not. So we can do that also. So that is that we can do for copyright infringement. So we can do that also. So anyway, these are the future plan. Okay, so thank you.